Rahman Rahim, dear student, share this video and also subscribe. The most important topic of chapter number 2 is product of vector. A product of two vector. As we add it, we can multiply it, we can divide. Therefore, we can multiply a two vector. There are two types of product of two vectors depend upon their resultant. If their product results into a scalar quantity, such type of product is called scalar product. And whenever we multiplied a two vector and their resultant is a vector, so there is called a vector product. So there are, in simple word, there are two type of product. One is called scalar product. The another name of scalar product is called dot product. In simple word, dot. And another is called vector product. Before to discuss vector product, we are going through a scalar product. So definition, when a two vector A and B are multiplied and the resultant which we get is a scalar quantity is called scalar or dot product. Why it is called dot product? Because we put a dot between the two vectors. Once again, if we have a two vector A and B and multiplied and the resultant which we got is a scalar, is also called scalar or dot product. It is also called dot product because we put a dot between the two vectors. Now we are going to discuss their mathematics. Let consider two vector A and B having an angle theta between them as shown in figure. जैसे कि यही पे दिखाया गया है. So we can say we want to multiply A dot B. So A dot B arrow is equal to, when you remove this dot, it will be equal to AB cos theta. A question is, why we are putting cos theta, why we are not putting sin theta? I want to explain here. Let these are the two vector A and this is a vector B. If you resolve this B vector into its components, so this will be a two component. This is A vector and this is B. This is Bx component and this is By component. We are finding A dot B as shown. अब उर्दू में इस B का अगर मैं यहीं पे, if we have a light source and this is the projection और इस B की शेडो जो है डायरेक्ट यहाँ पर आएगी, तो हम कहेंगे कि इस B का ये A पर क्या होगा, प्रोजेक्शन होगा, शेडो होगा. तो हम लिखते हैं when A and B are the magnitude of both A and B and cos is the cosine of the angle between these two vectors. Now consider the two vector A and B representing by a line OP and OQ having an angle theta between them in figure 2. The scalar or dot product, in fact, the product of the magnitude of one vector and the magnitude of the component of the vector B. So we can write here A dot B is equal to, simple word में हम लिखते हैं AB cos theta, but in explanation form A dot B is equal to A into projection of B on A. Projection of B on A is clear from this example. This is the projection of B on A. So we can write this one here. A dot B is equal to A, and the projection of B on A is the component is Bx. So you know that Bx is the component of B which is parallel to A. How we can find this one? Let figure. This is Bx, this is By, and this is B. Now you know that from this theta, if we want to find Bx, we want to find the Bx. So this is theta. This is those side which is perpendicular in front of angle, and 90 angle के सामने hypotenuse होता है, और जो remaining है वो cos theta यानी base. तो हम लिखते हैं cos theta is equal to base divided by hypotenuse. So which is the base? Is Bx. Which is the hypotenuse? Is B, is cos theta. So Bx is equal to B cos theta. So the above equation can be written as A dot B is equal to A into B cos theta. या simple word, A dot B is equal to AB cos theta. This is called scalar product. Now, if we multiply B dot A, then what will happen? Dear student, if we multiply B dot A, the same figure will be replaced in that way. This is B and this is A, and we will resolve A. So the equation will be B dot A will be equal to B dot A is equal to into B, projection of A on B which is equal to B into AX. AX is equal to A cos theta, so is equal to B A cos theta. Next. Dear student, scalar product is a commutative. What is a commutative? Commutative product in A dot B will be equal to B dot A. Why? The scalar product, the resultant gives which is a scalar, so therefore scalar having no direction. For example, the practical example of scalar product is the work. Work is equal to F dot S. Dear student, F is a vector quantity and displacement is a vector quantity. But when they multiplied, it gives a work which is called joule, and joule is the energy which is called scalar quantity. Therefore, it is called scalar product, or dot product. Another example is magnetic field B dot A. Magnetic flux is equal to B dot A. There is another example F dot V, power. Velocity, force is equal to power. Power is a scalar quantity. All these are the example of scalar product. So up to now, I want to again revise these two questions. Scalar product can be defined as when we have a two vector A and B, and we multiplied. If we have a two vector A and B, and when we multiplied the two vector, and the resultant which we got is also a scalar quantity, is called scalar product. Scalar product is also called dot product because we are putting dot between the two vector. Mathematically, we can write that A dot B is equal to AB cos theta. This is equation number 1. Now the question is how we can get this equation. So I have given this example A and B making an angle of theta. Now we want to project the resolve of the B into its component By and Bx. We will take those component which is parallel to A, so which is called Bx. the आपके ज़हन में ये क्वेश्चन है कि why we are not taking by. If we are taking by, that means we are taking vector product. It means it gives some sort of no result, because cos theta is equal to 0, cos 90 is equal to 0. Now let's say their mathematics we are saying a dot b is equal to a b cos theta, a dot b is equal to a projection of b on a. Projection means that we are talking about bx. From right angle triangle, bx is the base, so base is equal to hypotenuse, base divided by hypotenuse. Cos theta is equal to bx divided by b, bx is equal to b cos theta. Putting the values of bx in this equation, so it will be equal to a dot b is equal to ab cos theta, and a dot b is equal to ab cos theta. Similarly, if we multiply b dot a, so the same situation will occur, but the b will be here and the a will be there. Now we will project a into its component. So we will say the b projection of b on a, the b projection of b on a is ax. Again ax is equal to a cos theta, so it will be equal to b dot a is equal to b a cos theta. This shows that a dot b is equal to b dot a. इसका मतलब ये है कि a dot b जो है वो b dot a के बराबर है, क्योंकि ये दोनों स्केलर क्वांटिटी डायरेक्शन पे डिपेंड नहीं करता. तो therefore we are saying a dot b is equal to b dot a, which is called commutative property. Now we will discuss their properties, their characteristic in coming video. तब तक के लिए अल्लाह हाफिज़. Assalamu alaikum warahmatullahi wabarakatuh, and please share and subscribe my video. Thank you.